Okay, so if you've made it this far through the video, you've witnessed the differences between three unique types of tests with what we call t-tests. So t-test, as I said, compares either one or two sample groups against one another. So in the first case, a one sample t-test is exactly what it sounds like. It's one sample comparing the mean of, in this case, unit sales against some sort of a predetermined average. So we might say, on average, we sell 140 units. How does that compare to after our event took place? Independent samples t-test, we looked at different groups comparison, right? City A versus City B in this case, and their after event sales. And then the third was paired samples, and paired was the same group. So within City A on its own, how does that compare relative to before the event and after the event took place? So in this video, we're going to start off where we left off in the previous video. And the reason I want to start is because I want to show you something important before you switch from a paired samples t-test where you may have selected certain cases. So if I go here to data and I go to select cases, you might notice that if condition is satisfied, it's still selected. In other words, SPSS is still just referring to City 1 in our analysis. Now imagine we forget to leave that alone and we go into Analyze and we do an ANOVA. The problem would be that it would just look at City 1 results and not the three cities as a comparison. So to fix that, you can either click All Cases, or what I like to do is reset it. So reset will set it back to default settings and make sure that everything is selected accordingly, and then hit OK. So now we are ready to run our ANOVA analysis. So click on Analyze, compare means, because that's what we're doing in this video today. We're comparing means in different ways, and this time we're going to choose one-way ANOVA. So here is our one-way ANOVA box. We have our three variables: name of city, sales before the event, and sales after the event. So let's create an alternate hypothesis before we start filling this out. So in this case, we want to understand, is there a difference between sales after the event across the three cities, right? And we can't do that with a t-test. If you recall, t-tests we can only do up to two cities in the analysis. So we could either compare A and B, B and C, or A and C. Here, we can compare all three simultaneously using ANOVA. So ANOVA is great when you have three or more categories that you want to compare. Other examples of this in tourism research, we might look at some demographics, for example. We might look at education level, right? So there's more than two levels of education. There's high school, college, university, training, etc. We might look at income level categories, under 10,000, 10,000 to 20,000, 20,001 to 30,000, right? Anytime we have more than two groupings, we do an ANOVA. So in this case, we have three groupings. We have City A, City B, and City C, and we want to compare the after event sales for each one of these cities. Okay, so that's our null hypothesis. There is no difference in after event sales among City A, City B, and City C. And our alternate hypothesis is there is a difference in after event sales among City A, City B, and City C. Okay, so let's do this. So what do we want, before event or after event? Well, in this case, as I said, our interest is in after event sales. So we move that to our dependent list. And for factor, we're going to bring name of city, the city itself, over to our factors. And then we're going to select a few options. So here is called post hoc. A post hoc test will tell us where those differences are. So when you run an ANOVA, the results will only tell you that there is a significant difference or there is not. It won't tell you where those differences actually are. So for example, in this case, an ANOVA might tell us there is a significant difference among City A, City B, and City C, but it won't tell you which cities are actually statistically significantly different from one another. Well, a post hoc test can be thought of as essentially multiple t-tests all done at one time. Okay? This way you can say, what is the difference between A and B and C, and A and C within an ANOVA's results. So we're going to select the most popular way of testing using a post hoc test. Actually, each of these has their benefits and disadvantages, but overall, the preferred one is called Tukey. So Tukey is our post hoc test tool that we'll be using, and we'll leave all other information the same and hit continue. And then we'll select in our options. We'll get some of this data as well. So here we want the descriptive statistics, and we'll also collect the means plot. It's important that you exclude cases analysis by analysis and choose a 95% confidence level. This has been explained, the reason why we do this, in our one samples t-test video. So please refer to that so you understand why we select these options. And then hit continue and OK. So here's our result. So this is exciting because you can see that we have the size, the number of observations, for each of our city. City A had 27, City B had 25, and City C had 27 observations. Shows the means across the three as well. So here we can see right away that City B seemed to have the most sales, unit sales, 166 rounded up versus 147 for City A and 143 for City C. Okay, so this is an indication, not a confirmation yet, but seems to indicate that City B did better than the other two cities. But let's see. Next, we can confirm our standard deviation, our standard error, which is our standard deviation divided by the square root of our population size. And here we have our minimum and maximum values. So these are the lowest number of units sold for City A, and these are the highest number of units sold for City A, then City B, City C, and finally a total column to say, on average, what is our mean across the three cities, standard deviation, standard error, the least amount sold across all three cities, and the most sold across all three cities. So this is a descriptive table that just gives you some additional information. Here's our ANOVA itself. So our ANOVA, the way to refer to this is the same as we did in our t-test table. You want to look at your significance level, and you want to look at your statistic. If you recall from a t-test, the statistic was called the t statistic. Here, it's called the F value, or F ratio, or F statistic. It's the same thing as a t statistic. It just is the letter that is used in an ANOVA context. So it's still the difference between the means divided by the standard error of the mean. It's called F instead of T. Okay. So in this case, we can look at our rows. We have what's called between groups and within groups. So between groups is essentially our independent samples t-test in an ANOVA context. So in other words, this is comparing City A, B, and C across each other to see if there's a significant difference. Within groups is saying if there's any differences within each city overall relative to one another. So our research question will guide which of the two rows we look at. In our case, we want to know how the three cities compared, and therefore we're going to choose between groups or between subjects, ANOVA. So the sum of the squares is simply the squared results of the means sum, so the total, if you add these up. Degrees of freedom refers to the number of observations that are free to vary in a data set. We covered this in lecture, but here is an example of it in an ANOVA table. So here we have a degrees of freedom of 2. Remember, the calculation for df is n minus 1. Because in this case we're looking at 3 cities, city A, B, C, this 2 is simply 3 cities minus 1 equals 2. You'll notice that within groups, the degrees of freedom is 76. This is because, again, it's our 3 cities, the n for all 3 cities added up. So here we're looking within each, right, across all observations. So 79, and then that number is taken 3 points away from it because there are 3 cities. So for each city, we have n minus 1, n minus 1, n minus 1. So 1, 2, 3 numbers are free to vary across all 3 of those groups. And therefore, our df is 79 minus 3 is 76. Okay. So in this case, we have 2 degrees of freedom are between groups, a mean square of 3766.031, our F statistic, and our significance level. So looking at our significance level, we can confirm that there is a statistically significant difference among the 3 cities regarding their means, and that difference is represented here in the F value of 17.917 with 2 degrees of freedom. Okay, so what does that mean? So this is basically saying that there is a difference between city A, B, and C regarding the number of units that they sold. So we're going to ask ourselves now, is there, where are those differences? Unfortunately, an ANOVA on its own cannot tell you where the differences are. It only tells you that there is a difference, okay? However, don't fret because we can do a post hoc test to determine where those differences are. And this is here. So the post hoc test table looks at multiple comparisons. It's essentially multiple t-tests all done at the same time. So if you look at the mean difference column, any value with a star beside it indicates a significant difference. Okay, so here we can see city A versus city B was significantly different. However, city A and city C was not significantly different. The other rows are simply moving the cities around. So you'll notice this value is the same as this because city A and B is the same as city B and A, right? It's the same comparison. It's just a negative versus a positive because one is lower than the other. And we confirm it with the significance level of 0.001. So this table tells us that of the 3 cities, A, B, and C, that city B is significantly different than city A, and city B is also significantly different than city C. Another nice way to visualize that is through what's called the means plot. So we selected the option for means plot, and here you can see a big difference between city B, which is up here on a mean number of units sold, relative to city A and C, which are lower down in this visual. Okay. The last thing I want to show you is the strength of the differences. So yes, we know that it's significantly different and that this is the amount it's different by. We have what are called effect sizes. So an effect size is essentially saying how big is that difference? Is it a little different? Is it pretty different? Moderately, in other words, or very different? And we have some really good research to support the number that we choose for that. So I'm going to bring that over here. And this is a study that essentially says when we compare differences between many means, right? So this is ANOVA. Difference between two means is t-test. When we compare differences between many means, we look at our F statistic, and we can conclude that a small difference between many means is 0.10, a medium difference is 0.25, and a large difference is 0.40. Okay, so this is the effect sizes for an ANOVA, this second row here. So let's go back to our data, and we'll see what our point estimate is. That's how they report it. So our point estimate, eta squared, is 0.320, right? So let's come back one more time. 0.320 fits somewhere between a medium and a large effect size. So in other words, that's saying that we have a moderate to high effect size, meaning that the difference between between city B's unit sales and city A and C is moderately to high in terms of difference.